Hello students. In the last video, we discussed on the classification of colloids on the basis of physical state of dispersed phase and the dispersion medium. Now let us discuss classification of colloids on the basis of nature of interaction between the dispersed phase and the dispersion medium. On the basis of the interaction between the particles of dispersed phase and dispersion medium, we can say the colloids are of two types. That is lyophilic colloids and lyophobic colloids. Now let us discuss these two colloids in detail one by one. Let us discuss first Lyophilic colloids. What the term means lyophilic? Lyo words means liquid and philic word means loving. That means the word lyophilic means loving. Which loving? Liquid loving. That means they have greater interaction. That means liquid, that is a dispersion medium, and the particles of dispersed phase have greater interaction. We can say lyophilic colloids in this, the dispersed phase and the dispersion medium both have greater interaction, or we can say they have greater affinity to each other, or we can say they are loving to each other. Because of this reason only, they have more stable form of colloids. How we define lyophilic colloids? The colloidal solution in which the particles of the dispersed phase have greater interaction or affinity or love for the dispersion medium are called lyophilic colloids. I think the definition is clear. In simple words, we can say the greater interaction between the dispersed phase and dispersion medium, that colloidal solution is called as lyophilic colloids. Now, how we can prepare lyophilic colloids? When we add the dispersed phase with the dispersion medium, you can see when the dispersed phase and the dispersion medium, when you mix it, you will get lyophilic colloid. Just like a starch solution is actually a colloidal solution. When you mix the starch in a water, you will get lyophilic colloid. That means very easy to prepare lyophilic colloids. Therefore, we can say it's a ease of preparation. It is easy to prepare the lyophilic colloids. And if we want to remove the dispersion medium from the dispersed phase, for example, when you heat the lyophilic colloid, the dispersion medium and dispersed phase get separated. Or we can say by evaporation, if you remove the water content in the starch, that is from the lyophilic colloid. So again, when you mix the dispersion medium with the dispersed phase, what you'll get? Lyophilic colloid. That means if the dispersion medium is separated from the dispersed phase, say by evaporation method, and the colloidal solution can be again formed by simply mixing it with the dispersed medium. I think it's clear. Therefore, we can say that it is reversible in nature. It is reversible in nature because once you will separate it, again you can reform this one by just mixing them. So, we can say they are reversible in nature. Because of this reason only, Lyophilics are quite stable. That means it will not get precipitated easily when you add any electrolytes in it. Examples of lyophilic colloids are starch, gum, gelatin. Here we can use the word sol because we have already discussed the type of colloids on the basis of physical state. The solid in liquid is called as sol. So starch can be called as starch sol here. The next one is lyophobic colloids. What the term means, the lyophobic. As we discussed earlier, lyo means liquid and phobic words relate to hating. Hating, or we can say the fear. So the lyophobic means liquid hating. So liquid hating means here both the dispersed phase and dispersion medium, we can say they have no affinity. They are fear of each other. That means the dispersed phase and dispersion medium in lyophobic colloids have no affinity, or we can say no interaction between them. In the case of lyophilic, it have greater interaction, but in the case of lyophobic, they are hating to each other. Which one? Dispersed phase and dispersion medium. Therefore, we can say it have no interaction or no affinity. So, let us define the lyophobic colloids. The colloidal solution in which there is no affinity or interaction between the particles of the dispersed phase and the dispersion medium are called lyophobic colloids. As lyophilic can be easily prepared by just mixing, that we have discussed now. But what about lyophobic colloids? Lyophobic colloid is not easy to prepare because they are not easily formed. There is need of some special techniques and methods to prepare lyophobic colloid. So it is not easy to prepare the lyophobic colloids, and it is irreversible in nature because when you heat the lyophobic colloids, you will get dispersion phase and dispersion medium. And when you again remix the dispersed medium with the dispersion phase, you will not going to get this one. That means once you can separate the dispersed phase and dispersion medium, it is not easy again to make the lyophobic colloid by just remixing. So we can say it is not easy once again to prepare lyophobic colloid after separation of these two. So I think it is clear. Therefore, we can call it as this is irreversible in nature. It will not get reversed, and it is not easy to prepare. Because of this reason only, we can say they are quite unstable because they have very weak or we can say no interaction. Therefore they are unstable, and they will get easily precipitated. That means we can easily get precipitate by adding suitable electrolyte in it. Examples of lyophobic colloids are arsenic sulfide, sol, ferric hydroxide, sol, gold, sol. So one example, for example, it is easy to prepare starch with water. Just what you need to do, you have to take starch and you have to dissolve in water and heat it. But the same thing if I say you take gold and add it into the water and heat it, do you will get this type of liquid sol? No, not easy. So we need some special techniques. So let us differentiate between these two, that is lyophilic colloids and lyophobic colloids. In lyophilic, it have greater affinity And in lyophobic, it have greater affinity, it have no affinity. Lyophilic can be easily prepared by just mixing dispersed phase and dispersion medium. It is not easily prepared, therefore some special methods are required to prepare, that we will be going to discuss in the preparation area. It is reversible in nature, that means once the dispersed phase and dispersion medium is separated, it can again form the colloid by remixing it, but it will not form colloids after remixing. Therefore, it is called as irreversible. It is quite stable because of they have greater interaction. It is unstable because there is no interaction between the particles. It is not easily precipitated, and it easily get precipitated by just adding suitable electrolyte. So examples of lyophilic are starch, gum, rubber, gelatin, proteins. These all can be easily prepared. But the examples of lyophobic are, that is silver, arsenic sulfide, gold sol, ferric hydroxide sol. So these are the examples of lyophilic and lyophobic. So I think it is clear to you. Lyophilic, it is the interaction. If it is greater interaction, then it is lyophilic. If there is no interaction, then it is lyophobic. So that is all about, we have discussed about the two types of colloids on the basis of interaction between the dispersed phase and dispersion medium. So in the next video, we will be discussing on the classification based on the size of the particle of the dispersed phase. So thank you everyone.